now that we've looked at the preliminaries, we understand a hacking methodology, now it's time to have fun. Attack! It's time to attack. This is what a red team's all about, is attacking. So in attack mode, we have to start thinking about what are we going to attack? Well, remember our scope of work is going to define what we're going to attack. So when you want to think about attacking, you have to remember we have, in most cases, some type of defenses that are in place anytime we do a red team attack. So what we usually have is our black hat hacker out here, usually coming through the internet cloud, has a router of some type, a router for those of you in Europe, and out of that usually is what we like to call a bastion host. Usually we got what we call a public DMZ here, and a separate DMZ here. Then of course we have our internal network. That's our internal network, right? Now, the thing you have to remember is the hacker out here is a red team. When you're emulating a threat as a red team, as the hacker, we have right here is our first layer of defense. Well, that's the first thing we have to get through. And reality is, if this is a solid device, I can't get through it. My hack's over. The nice thing is, we know there has to be services allowed through for this public DMZ and services allowed through this separate DMZ here. Those services are what we're going to attack. So as we go through, the first thing we're going to encounter is what? A device. So the first thing we have to attack is a device. Well, guess what? If this device doesn't have a vulnerability, we're done unless we can attack the service that is allowed through the device. And reality is, in this internal network down here, in most cases in an internal network, it's using private addressing. So since it's using private addressing, we will not be able to attack this because it's not a routable address. We have to do what's called client-side attacks, as we'll discuss later, to have the client come to us, which is the new types of attacks pretty much we see out there. From a red team standpoint, we're interested in everything that's publicly visible to the internet cloud. So as the black hat hacker here, we're going to emulate that threat from the internet cloud and go in, and first thing we're going to hit is a device. So now that we're in attack mode, what do you think the first thing we have to learn how to attack? A device. So let's talk about the next chapter, which is attacking devices. Here's our objectives for the chapter. We're going to discuss the methods of attacks against devices, clarify switch attacks, identify router weaknesses, and review firewall attack techniques. Three main devices when testing we're going to run into. We're going to run into a switch, a router, and a firewall. You're almost always going to encounter these three devices because organizations deploy them. Reality is, if it's a well-configured solid firewall, we're probably not going to be able to attack it. But the good news is, the firewall is not really a wall. All right? It allows ports. So since it allows ports or services, we'll be able to attack those services. It has to allow some form of traffic. That's our advantage. It might be the only way to attack the network, is what is allowed into the network if it's a good administrator environment. Switch attacks. We can either flood the switch in most cases or do what's called port stealing. These are two main attacks we like to do against switches. A switch, when we flood it, we turn that switch into a hub. And think about how a switch works. If a switch knows everything that's plugged into its port, the IP address and MAC address, for instance, it has to maintain that somewhere. Well, it maintains that in what's called CAM, the Content Addressable Memory. Well, that's a finite size. And what we found is a tool called MacOff, from a hacker security researcher named Doug Song, years ago. MacOff could flood pretty much any switch in about 70 seconds. And when a switch floods, it usually fails open. Fails open means it turns into a hub or a collision device. It just constantly sends and populates all the packets it has out all ports. Recent testings proved it doesn't really work. Any switches post 2007, we can't really do the flooding attack against. But as an actual red team member, you might run into a switch that's an older switch, especially if you're red teaming environments, governments, and all those types of things, has an old network around, because we all know a lot of our switches last and last and last, so we don't replace them. You might have success flooding, but in most cases, usually not. Port stealing. It's an attack using layer 2 traffic. We take the source address of the victim and destination address of the attacker. What we do is we generate a broadcast ARP, address resolution protocol. We send the traffic to the real address after we steal it. This is how we usually defeat static ARP entries, all right, different types of things. Again, this usually is the type of attack you would use if you get in your scope of work on-site visit. If you don't have an on-site visit, you can't really do these types of attacks. Well, since we are looking from the outside, a red team hack, we want to talk about routing. What is routing? Routers exchange information about paths through a network. The network addresses identify each link, and it contains the names of the networks that it crosses along the paths. They use this information to determine what we call switching. And a router contains broadcast by allowing the network layer to find a destination. So when you think about it, when an IP address is on your machine, it goes and hops around the internet until it finds the router that owns that IP address block. And then the data is delivered to what we call the MAC address, the physical address. So when we're hacking, we can hack an actual routing address. So routers relay packet from one data link to another. We call it path determination and switching. This is not switching like a switch, it's switching in the network layer, which means we take it in one port and out the other. It allows a router to accept a packet at one interface and forward on a second interface. If any of you ever configured an actual multi-homed or a 2-network card computer, you know it won't send network traffic from one interface to the other interface until you turn on IP routing. And that's why you have to turn on traffic forwarding, because of the switching function of routers. So what is IP router? It connects 2 or more networks together. It routes packets based on the routing table. If no route's found, the packet dies. And it has a default gateway. That is, if I'm not on your local network, go ask the default gateway, they'll know the answer of where to go. Okay? So from a standpoint of our attacking, these routing tables, we can attack. If we can attack the routing table, we can circumvent or send the packets through the path of our choice. Here's an example in the diagram of an IPv4 routing table that you can see if you look at on a network. The first top one is on a Unix box, and the bottom one is on a Windows. Here's an IPv6 routing table for you. The IPv6 routing table, as you see, goes to that 128-bit address, which makes it a little bit more difficult to read. But in the hacking and red teaming concept, we will see red IPv6 out in the architectures, so we have to be familiar with it. So what's the steps of IP routing? We search for a matching host address that's requested. We search for a matching network, and we search for a default entry. So from the attack standpoint, I just try to corrupt or send out bogus routing information to cause the traffic to go another direction. And in fact, go through me, the attacker. Attacks against routers. We can hack the router itself. We can look at weaknesses in the access control list, which is quite common, or we can subvert the router configuration. And it's about the only things we can do against a router. Well, the good news is the router has software. It has an iOS, Inter-Network Operating Software, and it has its own bugs. Configuration methods, weak access to the router, telnet or clear text methods to the routers can be intercepted, and we potentially can compromise the password and get in that way. Or the web server. If they're running the web server on the device, it could have its own weaknesses too. So the software within the router itself might give us the vulnerability that we can use to gain access to the router itself. Okay, we're going to do a demo now and look at Cisco vulnerabilities, an open source vulnerability database in Searchploit, a tool in Kali Linux.